Alrighty, as you can see, I am not here today, and it's because I am at a meeting, and I've been chosen to, I guess, learn about these new resources that CMS will be unraveling, rather rolling out soon. And so, since your boy became teacher of the year, everybody want my attention. I tell you, oh, the paparazzi's just so thick. I can't even walk down the streets of Charlotte without somebody saying, "Hey, ain't that the teacher of the year?" Oh man, y'all, you don't want this fame. I'm telling you, you don't want this life. It's just so much, more money, more problems. That's what Biggie said. But anyway, let's get to the math. Let's review ways to solve quadratics. Let's get on my favorite color. You already know what my favorite color is. Where is it at? It will be lava. All right, let's ways to solve quadratic equations. So we know how to graph. This is by graphing. I just got finished eating some Cheez-Its and some of it is still stuck in my teeth. So you might you might hear me try to get it out. But anyway, all right, graphing. Remember we use graphing, we use the vertex. And so we find it's the x equals negative b over 2a to find the x of the vertex. And then we got a -3, and then we substitute it back into our equation right here to end up getting our y. So the vertex is -3, -1. Put it in the middle. And then we go above and below. And so, yeah. And then we substitute those all into the equation to get what the y's are, and then we graph them. And where the line crosses, the parabola crosses the x-axis, those will be our zeros. So this will be our zeros or solutions. And I said y-axis, I'm sorry, y'all, the x-axis, it is when y is 0. So we know that. So we also know that we can see this in roster form to be -4, -2 as well. Those are the solutions, those are the zeros, and if we were solving like this as well, we may call them roots because these are also the numbers that make the equation equal to 0. Okay, then we moved on down the road to square root method, and this happened when bx is not in the problem. And so we say, hey, we're going to use the square root method. We can just solve this like a regular equation. We would add 81 to both sides, take the square root, and we know when we take the square root of a variable, that number can be positive or negative to give me 81. So it's a positive and a -9.
Tiny interruption. Baseball practice is canceled.
Boom. Factoring using zero product property, which says that a times b, if a times b equals 0, then a is equal to 0, or b is equal to 0, or both a and b are 0. Okay? So we factor, right? And then we say you have to be 0, you have to be 0, or both of you have to be 0. So that's what we did there. Well, guess what? There is a new way of solving quadratics. It is called the quadratic formula. The quadratic formula is another way or another method for solving a quadratic equation. Be sure the equation is written in standard form, ax squared plus bx plus c. All right, y'all can tell when it's not 10 o'clock at night and I'm making these videos because I seem to have more energy. Yeah, because it's actually 2:32 in the p.m. Okay, so the quadratic formula. I'm going to teach you a song. I think Miss Barone taught me this song, and I cannot find it in this version. So I'm going to have to use my wonderful vocal pipes to sing the song to you to remember the quadratic formula. All right. And when I get back to school tomorrow, we're going to all sing it together. Yay. Smiley face, nose, happy, teeth. Yay. All right. So I'm weird, I know. Okay. So here it is. So negative b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. That's my, I gotta warm up again. I'm gonna slow it down because I think it was too fast for some of y'all, because, Sydney's probably looking around, both Sydney's in both classes like, huh, what? Jordan's looking weird, and then Ahmad is like, what language is he speaking? You know, he's slow for no reason. But we love Ahmad. We really do love Ahmad. He's a great person. That's why I put up with him. All right, here we go again. Negative b plus or minus square root b squared minus 4ac b squared minus 4ac all over 2a negative b plus or minus square root b squared minus 4ac all over 2a a and let me stop. All right, anyway, y'all get the point. So that's the quadratic formula, and we're going to use the quadratic formula to solve quadratic equations. So let's get to here. So before we go into the quadratic formula, there's a part of the quadratic formula called the discriminant. The discriminant is the part of the quadratic that is underneath the radical, okay? It is this part right here. This is called the discriminant. So what the discriminant does, it helps us do this. You can determine the number of solutions by evaluating the discriminant. So this is where we're going to use the discriminant, and the good part of it is it's in our equation, so it's going to help us figure out or help us solve a part of the equation. So the solutions or zeros is the value of x, go away, that makes y 0. See these things, they are so aggravating. Come up again, I'm gonna punch you. All right, the solutions or zeros is the value of x that makes y 0. We've been over this. This is the conceptual lesson, we know that, which will act as roots because they make the equation equal to 0 as well. So what we're finding today are solutions, and we're finding zeros, but we're also finding roots because they're making the equation equal to 0. Okay, I don't know why they have to use whatever. All right, if the discriminant is positive, you will have two solutions. So if the number under here is positive, which we'll see in a moment. Oh my gosh. If that number is positive, oh my God, I'm 7 minutes in. We haven't done any math. This is going to be a long video. If it's positive, then you will have two solutions. If it is, we'll talk about that later. All right, so if it's positive, we'll have two solutions, okay? If the discriminant, which means when you do b squared minus 4ac, if it is 0, we will have one solution, okay? One solution. If the discriminant is 0, we'll have one solution. If the discriminant is negative, we will have no solutions. So let's break down this. I am telling you that the quadratic formula gives you the solutions of your wonderful quadratic equation. Okay? So we know now that we can have more than one solution. With a parabola or a quadratic function, we know we can have at most two because the quadratic formula forms a parabola which looks like a U or looks like an N. And the solutions are where the line crosses the x-axis. So we know we can have at most two. That's why we see this positive and negative. It represents two. So therefore, when we're looking at the discriminant, if it is positive, that means we're going to have two solutions. Now, this is going to be an extra credit question tomorrow. Why is that the case? Why, if what's under here positive, why will I have two solutions if what's under here is positive? Okay? When you have what's under here is 0, then you'll have one solution. Why is that the case? Why, if I take this and I get 0 and I put it underneath the square root, why will I only have one solution? And if it's negative, you will have no real solutions. So why, when if I make this a negative number, if what comes up under here is a negative number, why would I have no real solutions? Why does this make sense? This is going to be extra credit tomorrow. I got to figure out a way for y'all to do it so that everybody that gets it right will have extra credit. All right. So x squared minus 4x plus 3 is equal to 0. Now, normally we would factor this, right? We'll say, come on now, Mr. O'Neill, we could factor this. We can say that this is going to be the same sign. Yep, you're working with me. Same sign. The sign is going to be negative. And I know that negative 3 and negative 1 is equal to 0. I know that the solutions will be x equals 3 or x equals 1. Okay, for something I forgot to say right here, which is very important for me to say again, back here, that the word or is kind of important. I don't know who said kind of. It's really important. Since x cannot be 3 and -2 at the same time. Remember, x is equal to 3. 3 makes this equal to 0, or x equals -2, or -2 is equal to 0. It can't be both at the same time. So I think I've used the word and before, but I'm saying that it can be both, but not at the same time. So, let me just emphasize that. But watch this, y'all. Today it will look like a whole bunch of extraness before we get to these other problems where it makes more sense. Somebody's about to come in my room. They are now gone. All right, so okay, I lost my train of thought. So yeah, these are the solutions. Okay, when you're like, Ms. Odell, I don't want to use this. Yep, you're right. And soon you'll know why you want to use this. So the discriminant is the part of the quadratic formula that has b squared minus 4ac. So if we write b squared minus 4ac, we can figure out how many solutions we're going to have. So b squared, so -4 squared minus 4 times, this is a is 1, 1 times c is 3. So -4 squared is 16. 16 minus 4 times 1, which is -4, times 3, which is -12. 16 minus 12 is going to give me what? 4. So this is positive, which means we're going to have how many solutions? 2 real solutions. Run out of room. Okay? So that I know that. I've proven that by factoring. I've proven this by graphing. You see the graph right here? And now we're going to prove it by using the quadratic formula. -b, oh, we don't need to write the -b, so let's just pull in the numbers. -b, notice this is a -4, the opposite of -4 is a +4. -b plus or minus square root. b squared minus 4ac, b squared minus 4ac, we already found that. b squared minus 4ac is our discriminant, which is 4. So we're saying, hey, it's the square root of 4 all over 2 times a, which is 1. So this is what this looks like. It looks like 4 plus the square root of 4 all over 2, and then 4 minus the square root of 4 divided by 2. It looks like a lot in the beginning, y'all. It will make sense real soon, because I can hear some of y'all complaining right now because it starts off easy. That's all I always set y'all up. So I'm really saying 4 plus 2 over 2. 4 plus 2 is 6. 6 divided by 2 is 3. And over here I'm saying 4 minus 2 over 2. 4 minus 2 is 2. 2 divided by 2 is 1. What did I just find? My zeros, my roots, my solutions. That's what I just found, y'all. And that's what I found right here. And that's what is represented right here as well. So I can zero product property. I can graph. I can spell graph. And then the quadratic formula. Q4. All right. We're going to do more. Yep. Get ready. But this one right here, we can say, Mr. O'Neal, now why would you tell me to use the quadratic formula here when I know that this is x plus 1 times x plus 1. This is a perfect square trinomial. This is 1 and this is 1. And then when you do that and together, you give me 2. I know this is a perfect square trinomial, which is really just x plus 1 squared is equal to 0, which pretty much tells me if I use the, if I want to use the square root method and solve this, I can have x plus 1 is equal to 0. That's not positive or negative 0. It's just 0. So I subtract 1 and I get x is equal to -1. So I can use the the square root method to get -1. I can use the zero product property and get -1. I can come over here and graph it and end up getting -1. This should be, yes, end up getting -1 right here. My solution, y is 0, x is -1. I can graph it. And then you telling me you want me to use the quadratic formula to figure out this same thing? Yes, for now. for now. Okay, so we're going to find the discriminant. The discriminant says that if b squared minus 4ac, well, now he's no if. Well, yeah, if b squared minus 4ac is positive, you have two real solutions. If it's 0, you have one real solution. If it's negative, you have no real solutions. All right, so b squared, b is 2, so we have 4, y'all get the point, minus 4 times 1 times 1. Okay, so we get 4 minus 4, which equals to 0. So that means I have one, y'all don't say 0 solutions. No, one real solution. I can hear Latrell tell me, where you get that from? Well, Latrell. I don't pass the Latrell. I get it from here. If the discriminant is 0, we have one solution. If the discriminant is positive, we have two solutions. If the discriminant is negative, we have no solutions. And y'all supposed to be figuring out why this makes sense. If this formula is the formula for the solutions to a quadratic function, why does it make sense? So I already found the discriminant. So I'm saying x is equal to negative, or I don't move down too much, negative b, which is negative 2 plus or minus the square root of 0, because I already found b squared minus 4ac, this is what it is, which is 0, over 2 times 1, which is 2. So in essence, I'm saying negative 2, and then add and subtract 0, which gives me 0 over 2, which is negative 1. So x is equal to negative 1. I can see that solving the square root method. I can see that if I come over here and I use zero product properties, x plus 1 is equal to 0. Subtract 1, subtract 1. X equals negative 1. I can see it from the graph. The solution is negative 1. Negative 1 when x is negative 1. All right, and I can see it using the quadratic formula. But why would, if this is 0, why would I end up with one real solution? Some of y'all can figure it out. The next one, Mr. O'Neill, you're saying x squared minus 2x plus 1 plus 2. So let's try to factor this bad boy. Okay, so I end up getting x, and I end up getting x equal to 0. So you're telling me there are two, I can multiply two numbers together, which will have the same sign, which would be a negative and a negative, because this is negative. I can multiply them together and get 2, and then I can add them and get negative 1. So there's only two numbers are negative 2 and negative 1, but they add together getting me negative 3. There's an issue right here. So this seems to be unfactorable or prime. This can't be factored. But prime, I need y'all to understand this. Prime does not always mean no real solutions, because prime means no integer solutions. I need y'all to get that in your head. Prime means no integer solutions. There are no integers that will multiply and add to give me this. But there may be some rational numbers, maybe some fractions, some decimals to do that. Okay? But in this case, there are no numbers to do this with. So this is impossible. Now, I hate saying this, but I need y'all to understand this. We are saying there are no integer solutions. The way that we know that there are no solutions is by looking at the discriminant. B squared minus 4ac. B squared. So we're saying negative 2 squared minus 4 times 1 times 2. Negative 2 squared is 4. Minus 4 times negative 4 times 1 is negative 4. Times 2 is negative 8. Well, that gives me a negative 4. I think in this problem, I'm going to kind of give y'all the hint. Before I even give you the way to get extra credit. So, negative 4. So, I will come over here and say that x is equal to negative b2 plus or minus square root b squared minus 4ac is negative 4 all over 2a. 2 times 1 is 2. So, y'all, this is a problem. This is problematic. And you should know why that's problematic, because this is a part of your extra credit. So, again, you should be able to prove why, when you have the discriminant to be a negative number, why you get no real solutions. Which means that the parabola does not cross the x-axis. You see this? You see any zeros here? You went from 5, 2, 1. Oh, no. Well, you know, if we had integers. You can't really prove it from the table because sometimes the numbers are decimals. But we can see from the graph. It does not cross the x-axis. No real solutions. All right? There we go. Those are your 3. Let's take a moment to review again. If you get a positive number, you have 2 real solutions. You get a number to be 0, or you get 0, you get 1 real solution. And some of y'all ask me, when can you ever have it to be 1 real solution? There it is. And when will you have it to be 1 real solution? You see that? All right. And then if you have it to be a negative number as a discriminant, you get no real solutions. So when is the quadratic function most useful? I think by now you know when. Let's see when. Use the quadratic formula to solve the equation. Round your answer to the nearest hundredth if necessary. So a lot of us will look at this problem and be like, Mr. O'Neill, I'm not using this long way of doing this. I'm going to try to factor. I'm going to factor by using slide and divide, which I'm not teaching next year because folks forget to divide, and I'm over it. So if I use slide and divide, I end up with, I'm going to do both methods. W squared, pick whatever method, and you can fast forward the other method. W squared minus W minus 10. Okay? And so you're telling me, Mr. O'Neill, that there are 2 numbers with 2 different signs that multiply to give me negative 10, but add to give me negative 1. Mr. O'Neill, the factors of the 10 are 5 and 2. 5 and 2 subtracted from each other is not going to give me negative 1. And then the other factor of 10 is 10 and 1. And 10 and 1 subtracted from each other do not give me negative 1. So some of y'all be like, this is no solution. That's a lie. That's a lie. That means it's prime. There are no real solutions. Sorry, no. There are no integer solutions. It's prime. No integer solutions. And the same thing here. If you didn't do slide and divide and you did the butterfly method, I mean, you still end up looking like this in the beginning, right? You still end up looking like this. You still will come up with the no integer solution. This is prime. But is it a no solution problem? This is where we say negative. This is where we take the discriminant, b squared minus 4ac. So negative 1 squared is 1. This is a 1. Negative 1 squared is 1. Minus 4 times a, which is 5, times c, which is negative 2. Well, 1 minus 4 times 5, which is negative 20, and then negative 20 times negative 2 is a positive 40. Y'all, we just ran into a problem. That b squared minus 4ac is 41. I should have 2 real solutions. 2 real solutions. Two of them. Okay? So when I look at this, I end up saying, hey, you know what? I have 2 real solutions, so I need to go on and finish using the quadratic equation. Negative b, which is 1, plus or minus square root, b squared minus 4ac. I already found that, Mr. O'Neill. It's 41 all over 2 times a, which is 5. So x is equal to 1 plus or minus the square root of 41 over 10. So now we see that we have real solutions that are not what? Integers. This is not a perfect square, which means that we're going to have decimal answers, irrational answers, for real. All right, so what we have to do, we have to now say that x is equal to 1 plus the square root of 41 over 10, and then x is equal to 1, I always want to write plus again, but it's minus the square root of 41 over 10. Ooh, we're 24 minutes in. We're almost done, people. So it says round your answers to the nearest. So 1 plus the square root of 41.
Pardon the interruption. Girls track practice is canceled for today. Girls track
Divided by
practice is
10.
canceled for today. If you need to come to the
So
office and make
x
some
is equal
arrangements,
to
do so now, please. Thank you.
0.74. It's 0.7403, but that 0 says keep this 4 there to the nearest hundred. And then x is equal to 1 minus the square root of 41, and then divided by 10. A negative 0.54. So what does this look like? This look like, if I draw a little mini graph right here, this is a narrow parabola with a y-intercept of -2. So if, for instance, I do it like this. So y-intercept of -2. It is going to open upward, but it's going to cross. I don't know my vertex. I'm not going to go through all of that, but y'all get the point. So like, pretend like this is 1. So at 0.74, it's crossing right here. Vertex somewhere down here, something. And then at point, and this is -1, like halfway right there, is crossing right there. That's what your parabola looks like. Something like that. Because I didn't try to find a vertex, you know, and all that stuff. But just a quick graph. That's what it looks like. So these points, that doesn't look like an X. These points are not integers. And that's the problem. This is when it's most useful, when we do not have integer solutions, zeros, or roots. All right, let's keep it going, Mr. O'Neill, because this video is going to get long if you just keep rambling. How many more problems? Ooh, we got 4 problems left. Y'all got calculators. Oh, I'm sorry, y'all. I have to emphasize this. You, in your calculator, don't write this down, but you cannot do this in your calculator. You can't do 1 plus the square root of 41 divided by 10. Your calculator is going to do order operations. It's going to say this first, and then it's going to add on 1 to it. That is not what we want. We want to say parentheses 1 plus the square root of 41, close your parentheses, divided by 10. Okay? Or you want to do it separately. Do this first, get an answer, and then divide it by 10. But I'm pretty sure y'all don't want to do all of that. So the majority of y'all are going to do this. Because if you do not, you're going to be wrong. And then you're going to say parentheses 1 minus the square root of 41. Close your parentheses, divided by 10. Because we want to divide everything by 10. This is dividing everything by 10. This is dividing the square root of 41 by 10. It will be wrong. So make sure you understand that. Ooh, this is going to be a class worth of video. You know, some of y'all fast forward going fast anyway. They're going to ask me, tell me you don't understand stuff. All right, so I'm going to tell y'all right now, if it says round to the nearest 100, more than likely these don't turn out evenly, so I'm not even going to check them. So I'm just going to do the b squared minus 4ac. And then for the rest, I'm going to tell y'all, just put it all in your calculator. All right, so let's see how many solutions are we going to have. So b squared minus 4ac. All right, so b squared is 7 squared, which is 49. Minus 4 times a, which is 2, times c, which is -9. So I get 49, and I already know that a negative times a negative is a positive. So I'm doing 36 times 2, which is 72. And then 49 plus 72 is going to give me 1, it's 11, 121. Ooh, look at this number, y'all. It's a perfect square, which means that when we put it over here, we're gonna get a perfect square. So we get 2 real solutions. Yay. Okay, here, look at here. X is equal to -b, -b, plus or minus this perfect square root. B squared over, no, yeah, I messed that part up. Anyway, all over 2a. Okay, I'm about to be interrupted again. Maybe not. All right, so I'm really saying that x is equal to -7 plus 11 over 4, and then x is equal to -7 minus 11 over 4. So -7 plus 11 is equal to 4, and then 4 over 4 is equal to 1. Woohoo! And then negative 7 minus this gives me a negative 18 over 4, which gives me negative 18 over 4 gives me a negative 4.5. So either way, we couldn't factor this into integers because this is not an integer, right? It just happens that 1 is. So roster form, negative 4.5 and 1 are our solutions, also our roots, also our zeros, also our x-intercepts. Yay. Okay, I'm going to do one more for the sake of the longness of this video, and I'm going to leave the next two to you all and then put it up somewhere. Maybe I think about putting it up. All right, so we end up with, I know now that this needs to be in standard form, so put everything over here. Put you over here, and then put you over here. So I end up with 4m squared, pen want to act weird, minus 7m minus 2 is equal to 0. Probably because this video is getting so long. All right, well, since I'm having technical issues, I think some of y'all will be happy to be done and to do this on your own. So yeah, that's how you start off the rest of the problems. I want you to verify your answers with your classmates. Please remember, oh, let me show you this shortcut real quick. So after I get this, I know you're like, well, you showed us in the beginning, because I want you to see the math behind it. So technically, everybody, we can put all of this into our calculator. I get x is equal to, it's going to be slow, and I can put in my calculator, in parentheses, some of y'all, negative b, which is 7. All right, it's not gonna work. Whatever. You're not putting this into your calculator, all of this into your calculator until I show up tomorrow. All right, great, because we're doing more quadratics tomorrow. I'm shutting this down, and we are done in 32 minutes. Oh, before I get done, it's gonna be a glitch, but whatever. At least y'all got like 20 minutes left. Oh, the highlighter doesn't want to act right. The pen doesn't want to act right. Oh, discrimination. Okay, so you just going to, all right, I'm out. I'm done talking to y'all.